Okay, a couple other concentration units that you might work with. So what you see, what we just looked at and what we've seen so far is that concentration is always the amount of solute divided by the amount of solution. It's an amount of one substance divided by amount of another thing. A combination of things or another thing. That's a relationship. So we can use those relationships to do calculations. Sometimes you'll be given the relationship with different units. Still a relationship, so we can still use those units to do conversions. So molarity is moles of solute. Oh, that's molality. Molarity, we just said, is moles of solute per liter of solution. This is most often used, most frequently used. Sometimes, though, if you're doing an experiment where the temperature is going to change, that will change the liter of solution. Right? Because when I increase the temperature, things move faster, they collide harder, they kind of spread out, and a liquid will expand at a higher temperature. So if I want to do a reaction where the temperature is changing, but I don't want the concentration to change, I can't use molarity as my unit. Because if I change the temperature and this liter starts to go up or down, depending on whether the temperature is causing the volume to expand or contract, then throughout the experiment, the molarity is going to be changing the whole time. If I don't want that variable to change, I want to maintain a constant concentration as a constant variable, then I would use molality. Molality and molarity are very similar, but molality is the moles of solute per kilogram of solvent instead of per liter of solution. Because a kilogram is how heavy something is. When I change the temperature and it moves around faster, it doesn't change how heavy it is. So if I do an experiment where I'm going to be lowering or raising the temperature, the molality of a solution is not going to change. The amount of the substances is not changing, even though they take up a little bit more space because they're moving faster and the solution will expand. So it's just like molarity, except it's just a slightly different unit on the bottom. When you're working with molality, which we'll work with more a lot later in the semester, you need to make sure you understand the difference between molality and molarity. But we wanted to introduce all the concentration units now, since we're talking about concentrations quantitatively. Another one is percent by mass. This is also very common, especially in medicine. Instead of using molarity, because a lot of times when people leave chemistry and they go into medicine, they forget what moles are. They're like, molarity? What's that? Percent by mass is just the mass of the solute in grams divided by the total mass of the solution, which is the solvent plus the solute mixed together, times 100 to make it a percentage. Right? So if I put 5 grams of solute in with 95 grams of solvent and the total becomes 100 grams, that's 5 grams of solute divided by 100 total grams, that's 5%. Right? Percent means per century. One more that you should know, it's especially used in environmental studies, is parts per million. Percent means per century or per 100. So a percent is just parts per 100, right? 5% means 5 parts of solute per 100 total parts, or 5 grams of solute per 100 total grams. Part per million is when you have a really dilute solution. So that would be if you had like 5 parts per million, that would be for every million grams, only 5 of those grams are actually solute. Right? So that's really diluted. So it's the same formula. It's the mass of the solute in grams divided by the total grams of everything, solute and solvent, times 1 million instead of times 100, because it's per million instead of per century or percent. And so it's pretty straightforward. But again, it's a relationship. You can use this as a relationship to relate the quantity of solute to the quantity of solution. Or in the case of molality, the quantity of solute to the quantity of just the solvent part of the solution. And so you don't have to memorize these definitions. They're on the formula sheet. But you have to be able to use them to do relationships. So here's an example. Here we have a solution. We're putting glucose in, a certain amount, in enough water to make a liter of solution. Then it gives me the density of solution. The density of something is the grams of that something per milliliter of that something. So if I have the density of solution, this is a relationship. That's 1.062 grams of solution per every 1 milliliter of solution. Right, so density is not the relationship between part of the substance and another part of the mixture. Density is the whole thing to the whole thing. The mass of the whole thing per unit volume of the whole thing. So I've got another relationship here. The problem is telling me I put this quantity of grams of solution per or equal to 1 liter of solution. I'm sorry, grams of glucose per liter of solution. So that's a relationship. Grams of glucose per 1 liter of solution. So I've got these relationships. I want to express this relationship with these other units. So we already talked about how to get to molarity. To get to molarity, I would take the grams divided by the liters, convert the grams to moles, and I would have moles divided by liters, which is molarity. How do I get molality? For molality, I need moles of solute per kilogram of solvent. So I need to put things in, find relationships that will allow me to relate the quantity of solute, which I have here, so I can actually put that in, to an amount of solvent. It doesn't actually tell me how much solvent I have. It tells me the total amount of solution, but not the total amount of solvent. So if the solution is the solvent that has been added to it, the solute, if I want the amount of solvent, I'm going to have to subtract. It's going to be the total divided by, the total solution minus the solute part of the solution. That will tell me how much of the solution is the solvent. But one thing I can do is recognize that if I want moles of solute and I'm starting with grams of solute, I need the molar mass. So we calculated that before. It's right here as well. So I can put that in here. So that'll cancel. So now I've got how many moles of glucose I put in. I need to divide that by the kilograms of solvent, and I'll have molality. So to find the kilograms of solvent, I need to find the total mass of the solvent, of the solution, and subtract the mass of the solute, the glucose. Right? The solution is both the glucose and the solvent the glucose is dissolved in. If I want just the solvent and I have the total, I can subtract out from that the glucose part, and I'll have just the part that's the solvent left over. So that's what they're doing here. So they use a density to take this liter of solution, convert that to milliliters, and then they use the density, this relationship, to convert the milliliters of solution into 62 grams of solution. So that gives you 1,062 grams of solution. Then the problem tells us how many grams of glucose there are. So if we subtract that, grams of glucose, that will give me the grams that are just the solvent or just the water. So I can put that here. The solvent. But this needs me to have kilograms, so then I would do 10 to the third grams per kilogram, and then I would be there. So I've got moles of solute per kilogram of solvent. That's what I want from molality. So I'll just multiply that through my calculator, and I'll get 1.06. Molality. So the abbreviation for molarity is a capital M. Molality is a lowercase italicized m. So good luck with that. Questions about that one? All right, let's look at percent by mass. Percent by mass is going to be grams of solute divided by total grams times 100. I've already got that information. I already got it from the last one. We know the grams of solute is the glucose, 170.1 grams of glucose. The total grams was calculated here, grams of solution. So I multiply that by 100, and I get the percent mass, which is 16.02%. If I want part per million, I would do the exact same thing. But I multiply it by a million instead of 100 per century. And that's going to give me this number in parts per million. Questions about that? Okay, let's take another short break. We'll work through some more examples, start to apply this to some chemical reactions. Actually, let's just do this last example since it's the last thing here before we go to chapter 8. So let's just do this last example, then we'll take a break. So here it's giving us some relationships. So we have rubbing alcohol dissolved in water, 70% by mass for the alcohol. That's a relationship. 70% isopropyl alcohol by mass. So 70% means per 100. So 70 grams of the isopropyl alcohol per or equal to 100 grams total. That's a relationship. The density is also a relationship. That's for the solution. So the solution is 0.79 grams of solution or total equal to 1 milliliter of solution. So I'm given some relationships, some information. I can express as relationships. I want to express that with different units. I want to express it as molarity, which is moles of solute, in this case the isopropyl alcohol, per liter of solution. So the given information I have is a relationship that involves grams of isopropyl alcohol, so I probably want to start with that. Since I want moles and I'm given grams, I always know the relationship between moles and grams is on the periodic table. So I would probably start with that, 70 grams. So I'll just give a decimal here. They should really have a decimal there. You're never going to have that with only one sig fig. They're going to give me at least 2 sig figs. So 70 grams of isopropyl alcohol per 100 total grams of solution or total solution. So I've got to convert the unit on top from grams to moles and the unit on bottom from grams to liters. So to do the grams to moles, I need the formula. I'll add the masses on the periodic table. So I've got 3 carbons. I've got 8 total hydrogens. And I've got 1 oxygen. So that's going to be 60.09 grams of isopropyl alcohol per mole of isopropyl alcohol. I'm getting closer. I've got the unit I want on top. Now I need to fix the unit on the bottom. What's the relationship between grams of solution and volume of solution? Well, that's the density of the solution. So I'll use that relationship next. I want to cancel grams of solution. I'll do 0.79 grams of solution equals 1 milliliter of solution. Now I'm getting closer. I want liters, but I've got milliliters, so I just need that relationship, 10 to the third milliliters per liter. So I've got liters of solution now on the bottom. That's what I want. So now I just plug in 70 divided by 100 divided by 60.09 times 0.79 times E3, and I get 9.2 molarity. Part B, I want molality. It's a little bit different. Here I want moles of isopropyl alcohol per kilogram of water. Same unit on top, but instead of the total solution volume, I want just the mass, kilograms of the solvent. So similar to the last problem, if I have information about the total solution and information about part of it, I can subtract that to get the solvent part of it. Subtract the solute from the total to get the solvent. But my instincts maybe would be to start with the same information I started with last time, because if I want the same unit on top, I can get that the same way I did in the last problem. So grams per 100 grams of solution, and use the 60.09 grams of isopropyl alcohol per mole of isopropyl alcohol. So that cancels here. So I've already got the unit I want on top. So now I need to somehow figure out a relationship between the total grams of solution and the amount of water that's in that. How do I figure that out? It doesn't say outright in the problem, but it is implied, because the solution is made of what? Isopropyl alcohol and water, right? So if it's 70% isopropyl alcohol, what's the percent that's water? 30. So that's another relationship. It doesn't say it outright, but that's a relationship. 30 grams of water for every 100 total grams. So I want the total grams total of solution to cancel. So for every 100 grams total, 30 grams of water. That relationship allows me to cancel grams total. And now instead of grams, I just need kilograms. 10 to the third grams per kilogram. So now I've got the unit I want on the bottom. So then I just plug in 70. And I can see if I want that the hundreds cancel, I don't have to worry about that. Divided by 60.09 divided by 30 times 10 to the third gives me 38.8. And really I should have two sig figs here, so I'll round that to 39. Molality.